the Epsilon solution. So very briefly, Epsilon is a family of languages which are tailored for slightly different model management tasks, such as transformation. This is the constant transformation, the very first thing, and this is written in the core language called the object language. And you'll notice this is very similar to OCL. It has some extra things like statement sequencing, so we terminate our statements with a semicolon and so on. But by and large, it's OCL with some extras, like you can manage multiple models at once. So this is the constant transformation. In Epsilon, you just go through the typical like run configuration and select which model you want to execute on. So I've done that in advance. I can run this, and this will produce an EMF model that conforms to the meta model, and that's the greeting. Okay, so that's the constant transformation. This is what it looks like with references. So here we have to create two more objects, and I've just placed them directly into the empty reference, and then set their text value. I could have made these into a variable and accessed it that way, as you'd expect. And for the rest of the, so yeah, there's some more EOL in here, but I'll start to show some of the specialized languages. So we have, for example, a language that's tailored to model-to-text transformation. So I use that to do the concatenation. It's a little bit of overkill here because the only bit of concatenation that we're doing with fixed text is this white space here, this one space character, and the exclamation character. But you can imagine when your document features quite a lot more static text, this language is a bit more useful because you can embed EOL statements in these dynamic sections and just keep your fixed text in these unhighlighted sections. So if you've used something like PHP or one of these template languages on a server, it's very similar to this. We just use this funky looking symbol to output something from EOL. So that's the model-to-text language. Let me just show you that running. We get something. Oh, okay, because I moved the file on. So what you would get is that message in the console. But I moved some files around and forgot to update the launch configuration. So this is a slightly more complicated bit of EOL that does accounting of the different nodes. So this counts nodes and leading edges. All this does is print out the results. So this is the syntax for accessing all of the nodes in the model, and that's the size of that collection. We've got these statements from OCL, these kind of higher order operations that take, this one takes a predicate. So this operation takes an operation and filters the collection by this. These are quite nice. And you can also define your own operations on existing types. So if your meta model defines a node type, you can define an operation on it and then use that whenever you refer to a node. So this is quite a nice way of capturing logic that's not captured in the meta model. So these guys are very similar. There's another language called the Epsilon validation language, and this contains some more declarative parts. So this is a mixture of the imperative part of EOL and the declarative nature of other languages. This allows you to specify constraints that you can run on a model, and you can also specify fixed parts. So this constraint checks to see whether this particular edge is dangling. If it is dangling, then this fixed part will be activated. We'll get this message, the edge, whatever, is dangling. And we can click on the GUI, and you get an option. You can select remove this edge, and then it executes this do part here, which will just delete the edge from the model. So this is a really good way of specifying both constraints and ways of fixing any inconsistencies. And I would show you that running, except I think it's going to blow up as the last one did. So we looked at migration last year, so let's not talk about that. Okay, yeah, we have like 20 seconds, so I can show you very quickly. So we have a language specific for migration called Flock. And what this does is it automatically copies from the source model to the target model anything that's not been affected by meta-model changes. So here, for example, edges weren't affected, so we don't need to specify a rule for edges. They're just copied automatically. We only specify rules for things that change. So that's the block. Right, don't look for a minute, because I'm going to break our own rule. I wrote mine. I'm not. This is just for me, so this doesn't count. So these are the opponent statements. So the main things that people noted were that the solutions seem fairly concise and readable because it's. Yeah, I know. This is just for me. We said no slides, so officially I can't show you this room. The statement said that mostly the solutions seem concise and readable, which is great. I think this might be because it's fairly similar to OCL. It's not too much of a leap from OCL to core language, EOL. There is one thing I want to quickly show you. For the part of the case that needed slightly more sophisticated pattern matching, so there was this case where you had to count circles. In EOL, this is really ugly because we need lots of imperative code. So let me show you that very quickly. Count circles, I think it is. So look, this is what this looks like in EOL. So we actually have to iterate over everything. If we find two nodes to be the same, we have to exit the loop and continue and so on. And there are some really nice declarative solutions to this. So I think that's one area that we'd like to improve. EOL, perhaps pull in some of this nice declarative syntax that you guys have. And the other thing that was asked was mainly about improvements to development tools like auto-completion, static typing, this kind of thing. We have an army of undergraduate students working on this at the minute, and it's coming. We released a new version of Epsilon a couple of weeks ago with a debugger in it, so that's the first output from this. So yeah, this stuff is coming, but it's not ready yet. Okay, so any questions, remarks, anything that I've missed?
Yeah, you say naming edge no source and or no target. So that means if you have no source and no target, it's also naming edge. I think that's not intended by the description.
Oh, okay. Yeah, yes. This problem with naming edge. Yeah, I think we could support either case. It would just mean changing this operation. I think maybe I interpreted this part of the case differently to other people. I saw on the forums there's this problem. But yeah, it would just be a matter of changing this operation.
Okay, then let's conclude for Epsilon. Thanks, Luis, for
Thank you.
Maybe one last remark: the Epsilon group has a record number of contributors to the solution. So. Also,
I'm learning the art of delegation.
So, yeah, you can take the cups for your
so
next.
Yeah, actually it's me again because Marcus